to track down the source of the error, first of all, let's see this error actually occur. Now, before I do that, I'm going to right click my project, go to project settings and turn on display compiler output. So any syntax errors will actually now appear in this terminal window. Right, syntax errors are saying nothing. There's no errors at all. We have a logical error. Actually, in this case, it's in the test bench. So I'm going to build all, and then in the library view, let's run the test bench. Select the signals we wish to view in the waveform. Press Ctrl W. That's the quick way. Okay, resize that so I can see them. And now I'm going to run all. Okay, now little tip, click in the waveform window and press F, and that will zoom to show the complete waveform fitting the width of the screen. And we notice down in the terminal there are two timing errors, one at 150 nanoseconds and one at 250. A nice feature in ModelSim is if I double click that, it actually shows you where they are. And so what we can now do is we could zoom in on this and work out where it is. Let's look at the second one, and it's there. So it's coinciding with the rising edge and the output going low, and then the rising edge and the output going high. And to cut the story shorter, if we look in the test bench, it actually looks fine. So why are we not seeing a 1, for example, at this point, and the 0 at this point? All right, so if we look in the test bench, this corresponds to here. That's the first one. So wait for the clock to rise, then we check it to 0. But this is what's causing an error. If we look in check output, it's just a procedure that does an assert. So it tests this condition, that the Q output signal equals the expected, which is passed as a parameter. And if it's not true, we get this report with severity error. So why is it not the value we're expecting? Looking at the timing diagram, it would seem to be the correct value. But of course, we're testing it just as the clock has changed. So this is a simulator resolution issue. Okay, another tick of the simulation, and that output would indeed be seen as high, and in this case seen as low. So what we need to do is we need to defer checking the output just slightly after the clock edge, not on the clock edge. Pretty much like you would do if you really had propagation delay in the system, which of course we don't. So even functional simulations can cause us problems. So there are a few ways we could do this. Well, I could insert, for example, in here I could put wait for 1 picosecond. Okay, make sure the simulation is not running actually. So I'm going to save that, compile all, and now if I run the simulation again, I should have squashed that error. Indeed I have. I've only got the 1 now. So I could insert delays throughout my test bench, but that's repetitive. I'm more inclined to put it either in the wait for clock rise procedure or check output procedure. So I'm going to go for the wait for clock rise and fall. And we're going to use another attribute, which is delayed. So what we're going to do is not going to wait for the exact time the clock rises. We're going to wait for a delayed version of the clock to rise. So that gives the output time to be updated, and then we'll look at it. So in wait for clock to fall, the new attribute is delayed, brackets 1 picosecond, then the event. Okay, and we'll use exactly the same one for the clock rising. Okay, so effectively what we're doing is we're not waiting on the clock edge to rise. That's already happened. We're waiting on a slightly delayed version of it and then checking the output. Right. So save that, compile all, run the simulation. Again, let's add those to the waveform, and we'll run to completion. And the good news is that down here we are no longer seeing any errors.